Okay, so now that we know what equilibrium is, our next topic is, well, how do we shift this equilibrium? How do we make more of one chemical and less of another, right? Like we can imagine that, maybe we have this pink cobalt, attached to this water, and then some chlorine ions, right? Maybe these are like extremely cheap chemicals, and we don't really want these. We want this thing. Maybe this thing is valuable. So we know that they're going back and forth. How can we get this reaction to favor this side so that we end up with more of this cobalt chloride, okay? So that's our big goal here. It's called Le Chatelier's principle, and it's how do we shift the equilibriums of chemicals so that we can make more of one thing or less of another. There's a bunch of ways to do this. So one of the first ones is concentration, okay? So this first video will be on concentration. So remember what we mean by concentration, right? If we go back here to our chemicals, concentration is basically if you have a beaker with water in it, how many of those chemicals are in there. And you should know from your rates of reaction lab that if you have more chemicals, there's going to be faster reactions, right? As they bump into each other, they're going to have a chance to turn into the new chemicals. And so the higher the concentration, the faster a reaction goes. So one of the ways that I like to explain Le Chatelier's is you need to imagine, right? You have, again, this reaction is coming together. These two things are coming together to make these things. But also, because this is an equilibrium reaction, that these things come together to make these things. So we have two chemical reactions bouncing back and forth constantly, right? So if we want to make this work better and shift this way, one of the things we can do is increase the concentration here. So imagine we increase the concentration of these chlorine ions. So we just dump a bunch of chlorine ions into our beaker filled with this hydrated cobalt. Well, what's going to happen? Well, we know that this stuff, this pink cobalt, hydrate, whatever this is called, turns into this cobalt chloride whenever it bumps into a chlorine, or some of the times when it bumps into a chlorine. Well, we just put a whole bunch more chlorines into our beaker, which means these guys are going to be bumping into those chlorines way more often, which means there's going to be a lot more chances for this to go this way and turn into this. But what about the other side of the reaction? Like, do these guys get reacted if there's more chlorines next to them? No. If this guy bumps into a chlorine, look, nothing happens. There's no chlorine on this side of the reaction. If this water bumps into a chlorine ion, nothing happens. So this reaction's happening better. This stuff is getting hit more often with the chlorines and having a good chance to come this way. But this stuff isn't really affected. It's not going to be better at going this way. And so what ends up happening is we shift our reaction to the right. So we could describe this as the reactant equation is favored, which shifts the reaction to the right, producing more of our products. So if we dump more chlorine in, we would expect to have less of this stuff because it's getting used up by the chlorine, but we're going to have more of this and this, right? And so we're going to have more of our blue chemical, right, and make lots of money, right? The whole point of this is we want to get the more valuable chemicals. So that's one way that concentration can affect it, right? You can add more of something to increase that reaction. Well, what if we do it on the other side? Like let's say that this blue stuff is cheap, right? We don't really care about that, so we're going to throw a bunch of that into our beaker. Well, how is that going to affect our reactants over here and our water over here? Well, this time we've added a bunch of this stuff, and we know that when there's a lot of this stuff, every time it bumps into these water molecules, it has a chance to react and create this stuff and this stuff, right? Well, we've just added a bunch more of this. So now all of this water in our beaker has a much higher chance of hitting into these and creating this reaction. So we're favoring the product reaction, which is going to shift our equilibrium to the left, right? We're favoring this reaction happening, and we haven't really done anything to change how this reaction happens. So now more of this is going to happen, but this is going to stay the same. So that's going to shift everything this way. So what's going to end up happening is these water molecules are getting used up by all the extra cobalt chloride, which is going to cause the reaction to happen, which is producing these things over here, right? So you're going to get more of these guys. And again, I don't want you to memorize, like, oh, if there's more of this concentration, it puts more of these. Don't memorize. Just think. You have two reactions happening. Whatever change you make, whichever reaction it makes easier is going to happen more, and it's going to produce more of the other side, right? So just remember it that way, more logically, right? More critical thinking. Okay, so that's concentration. So in both those cases, we increase the concentration. Well, another common thing that we can do with chemical reactions is to take away things or decrease the concentration. So let's say we take our blue chemical again. Let's say we take this out. let's say we have a way of harvesting our cobalt chloride. Every time new cobalt chloride is made, we have like some sort of chemical scrubber that can just pull it out of the solution. How is that going to affect our equilibrium? Well, think about it. Remember, let's do this logically. How does this affect our chemical reactions? These guys here, do they need the cobalt chloride for anything to do their little reaction? No. They just need this thing and this thing. So taking this out will not affect these guys. But our waters need cobalt chloride to react and go back over here to this way. So if we take out cobalt chloride, we are basically stopping, or at least slowing down, this whole reaction here. So this product reaction going this way is not really happening much anymore, but this reaction is still happening. So this reaction is still producing these guys, but this water, there's no cobalt chloride for it to react with anymore, so it cannot go back the other way. It's kind of stuck over here. So what's going to end up happening is these guys are going to keep getting used up and reacted, which means they're going to go away. And we keep taking this cobalt chloride out, so this water has nothing to react with, so it just keeps getting built up. Okay, so again, we've shifted our reaction this way because we've stopped the product reaction, this guy, but this guy keeps going. And so we're lowering the concentrations here. Every time they bump into each other, they react and create these. We take this out, water can't react, and so water builds up. Okay, so that's a couple different ways to change the equilibrium concentration. You can add more of something and it'll shift it the one way, or you can take something out and it'll shift it towards it. But again, don't spend time memorizing, okay, if I take it out, it shifts it towards it. That's not helpful because you're not, like a month from now, you're not going to remember that. But if you remember, if I mess up this chemical reaction and don't let it happen, then the things over here are going to build up. As these guys keep reacting to produce more, these guys will kind of stop, right? So that's the way you need to remember it for concentration. Okay? And if we go here, let's see.